Hello everybody. Today I'll be defining three kinematic measures of motions and I will be describing one way to calculate each measure for a specific movement. And to start off, we have the change in the spatial location of a particular limb or joint during a movement is called displacement, and this is our first kinematic measure. And in order to determine the location of the movement or mark joints at any given time, we use a movement analysis system to calculate displacement. And depending on the analysis system being used, the analysis takes samples of spatial positions at different rates, and this can be seen like through a typical videotape sampling, or that has a sampling rate of 60 hertz, meaning that if 60 times a second a spatial position is being recognized and recorded. Then the second kinematic measure of motion is velocity, which is more of a time-based derivative of displacement. And then velocity, which we like normally call speed nowadays, refers to the rate of change in an object's position with respect to time. And then that is how rapidly this change occurs. But it's also important to know, or like to recognize that it's in what direction the change is being made. And movement analysis systems derive velocity from displacement by dividing it by time. And velocity is always measured on a graph as a position by time curve in which the velocity curve is based on the same movement as the displacement curve. And we refer to velocity in terms of an amount of displacement per amount of time. And so a good example of this would be that a car takes 3 seconds to move 15 meters. Its velocity would show a rate of change of 5 meters per second. And then lastly, the third kinematic measure, acceleration. And this describes a change in velocity during movement. And we derive acceleration from velocity by dividing change in velocity by change in time. We also depict acceleration curves as a function of time and are often measured with curves on a graph, just like the way velocity is being measured. And for a quick little example is that a car's velocity increases from 5 meters to 15 meters over 2 seconds. So the acceleration would be 5 meters every 2 seconds. And that's how it would be seen on a graph, just through a curve. And it is pretty similar to the previous motion, but that's just how it is. But yeah, thank you.